Yeah, welcome everyone. Thanks for the introduction. This is actually the name of the company. I'm one of the partners. We also have a booth. Come by. First, a little bit of background. How did this talk come about? So, as Christian mentioned, I'm around at many conferences, so I talk to many data scientists, I talk to many experts. I think this year with the calls for free conferences, I read about like 1,000 proposals for conference talks. This gives me one good perspective on the expert side, but when we work with clients, I also hear their side and where they are struggling and what they think they should do and not. And this is the perspectives I want to share. And yeah, and my first question is, who's data scientist or an expert in Python? Okay. And who's more like in the management or like organizing project management position? Okay. Welcome you all. And I see very often. So let's first start with where we do stand. So let's start with the data scientist perspective, and let's start with a happy data scientist perspective. So if I speak to the happy data scientist, they say my work is appreciated. I can live up to my full potential. I'm highly trained. Very likely you're a curious person who wants to provide value to your company and solve problems, improve, and have a high standard also in ethics and everything. But I also talk to many data scientists who are not so happy. They work at a big company and they feel limited. They say, I'm a data scientist. I can do deep learning. I can do machine learning. I have many ideas, but actually I'm tied up. I'm working as an analyst, and they're like not so happy and torn because they're probably not heard. Since I expected to be have more experts in the room, I want to have a little bit broader perspective on what is probably the manager's perspective here. So actually, I found something online, how managers spend their time. So of course, a lot of it is administration, solving problems, collaborating, strategy and innovation is only 10%, and developing people and engaging stakeholders 7%. So you just see they're busy with many other things where you maybe say, I'm doing code review or solving bugs or so. This is maybe probably their part here. And also, quite interestingly, there was also a survey which managers think which skill they will need to success in the next 5 years. And actually, I was quite surprised the people skills. In my opinion, very underrated, because I think the biggest problem in all technology we solve today, basically, I think the biggest problem is actually human interaction, communication, and everybody has the same understanding how to solve the problems and where we really want to go. I think that's the main challenge. While, of course, technology is moving at light speed. So, okay. If we Google managers, so I Googled, you cannot read, actually, how is it? I Googled AI for managers. We get like the typical pictures. My favorite white Android robot. This is like the quite false perception of AI, but it's pretty sad in culture nowadays. But I also Googled replacing managers, and this is the other perspective. This is the first hit with AI, technology replacing managers. So, but there's also tools like AutoML and stuff like that. So what about data scientists? Replacing data scientists, will AI? Is still a question. It's not a proposal yet, according to Google. And if you're a data engineer, you're like super lucky. Yes. But we see there's a lot of buzzwords, hype, promises around, and I think many people feel like this, like it's like a crazy party, where we're actually moving, but we need to do something. So let me tell you a story. I recently met an old friend at the train station. So the person was very excited to tell me about coming back to the hometown, and had a new position in like top level management. And we talked, hey, what are you doing now? And I said, I'm with data scientist. I'm partnered with people, and we run Königsweg as a data science consultancy. We advise people on data, big data, and AI, and said, oh, great, AI. In my new position, I have to buy AI as well. And I was just like, okay, context. Very skilled. It's like a highly intelligent person. It's not a dummy. And then I just like thought, okay, how do I imagine I have to buy AI? So is it Aufschnitt oder am Stück? Yeah, cut a piece. So how do you buy AI in 2014? But we talked longer, and our company also understood what the real problem was, that in the company, which had to be addressed. And of course we solved it. And I want to share some of how we solved it, because a big part is actually understanding, what the problem is, what the challenges are, and get a better and honest perspective on things and how to operate. So let's start with the definition. Data literacy is the ability to collect, manage, evaluate, and apply data in a critical manner. So, if you're a data scientist, you're an expert. This is basically all you know. You know tons of stuff. You go to conferences, you have a lot of input, you're a creative person, you have many ideas how to solve. And very likely, especially if I talk to about myself, I like to solve problems, actually. So I know a lot. And of course, I always try to be transparent with my work and my approaches. So I like to share, okay, this is the background, this is how it works. This is probably also the reason I give many talks. But also, if you talk to your peers, always think, don't try to explain everything. Just explain what they need to know. Remember, keep it to the point. You know this. If you're from Germany, you know these two guys, like the mouse and the elephant. Now, explain it in a simple way. And let me take you to data here. There's like 4 levels of data. We have data collection, we have to manage the data, we have data evaluation, and then we finally have the application, which is like the nice part with all the machine learning, everything. So now let's just like walk through here. What has somebody in management or on a decision maker have to understand actually about this? Does he or she or them have to understand actually data collection? No. Everything, the data is collected. Great, it works. That's all they have to care about. What about data management? People work in enterprises, every have a job. Usually you work with experts and people who know how to do things. Of course, data management can be complicated, but if you know the data is being managed properly in a good fashion and redundant fashion, and all you need, depending on your needs, is managed. That's it. That's the key message. Yeah, it's being managed. Now, if we come to data evaluation, it's not that simple. Data evaluation, basically, we can pin it down like to these 6 parts. We have data tools, we have data analysis, we have interpretation and understanding, we have data visualization, we have presenting data in an oral way, so this is not the same as the visualization, and we have data-driven decision-making, and which parts actually somebody has to understand better to make a decision. I think the tools don't matter. They matter to us. We want to have great tools when we program and solve problems, but it's irrelevant which tools actually are used to solve things. We have data analysis. We need to have some knowledge about this. Very important is interpretation and understanding of the data. What can we do with it? Data visualization is always nice, but actually it's more important. How can we present the data in like a presentation? How can I explain it to somebody just maybe in a meeting or a phone call without Seaborn and all the cool tools we have? And also it's also, of course, important how to make the data-driven decision-making process. So basically we have a mixture, but we see basically data evaluation is the first part. We have to dig a little deeper in some ways. And what about data application? This is basically the most talked part, data application, and this is where all the work is actually, well, most of the work is. Let's look here. We have data ethics, data citation, Data citation, if you don't know it, is like if you cite from, for example, scientific data from somewhere else. The data culture, data sharing, this is more like sharing data between your peers, critical thinking, and the evaluating process, and evaluating the decisions. And if you look here, of course, data ethics is super important. You have to understand how you work with the data, various data sets. I think we have a lot of heard about this at the conference and previous conference, also in the keynote yesterday. It's important, but maybe not the most important. Data culture is important. Critical thinking is actually what people trust the experts to do the critical thinking. So you have to know there's critical thinking involved, but that's the short message here. So that's what needs to be known. Data citation is irrelevant. The data is just like there. Also like the sharing, how you share the data is not relevant for the decision maker. But the evaluating decisions, but that's basically the outcome. That's the predictions and everything. Of course, this has to be understood deeply. But you see, tackling down, maybe from everything I put here on the slides, maybe you have to get other people in your team or decision maker maybe only on board with like 10-20%. Okay, so here we go. Just in short, I just want to point to this. Also, if you talk in teams or companies or with clients, there are different personalities in the field. And I think Peter Baumgartner, he works in NLP. He gave a talk at Spacey IRL earlier this year here in Berlin. It's very he narrowed it down to these 6 personalities you can also run while running projects with them. And I just want to show, like, for example, let's show off Sarah, who just wants to do AI. He stereotyped it a little in a very funny way. Just look it up later. I think this is very useful input because there's these different types of interests here, and I think he narrowed it down really good. Of course, the decision maker also has to know it's not the IT department you have to talk to. We are not doing an IT project. The IT department, of course, will operate everything we produce, but at first, data science and AI is research and development. Now, once we go to production, we have to involve the IT department or to get resources to do the research. But we need to have an open space and an open mind to address the problems, to bring the value to the clients or to the company you work with. And this is very often overlooked. They see, okay, it's data, it's programming. Okay, let's talk to the IT department. The IT department, in many big enterprises, the IT department is actually just like mostly configuring tools from other companies. They're probably not even super capable of programming. Maybe they have just some basic skills, but basically they operate more. Some misperceptions. One misperception is also, bigger is better. So, I just buy the Hadoop cluster and then I'm set up for the next 10 years. And I bought also like, let's buy Watson and we're set up with all the knowledge. But that's, it's also say, okay, we don't need the big resources. We should invest probably in other areas. And another misperception is like a data lake, because this is like also like nice pictures. Data lake is really like, nice clear lake. It's not. A data lake, for example, is a complex system which involves many other systems. Basically, it's more like a thought concept than a nice lake. You can just like pull the data out. So these are all like things you have to point out. Very often, I see I see ourselves confronted that the problem seems just to be simple to the peer we talk to or the person we talk to, is because there's no experience. So you hear all the hype and I said, it's easy. I mean, you just throw deep learning at it and we'll solve it. And we have to point out, no, we should use classical statistical methods first because they're stable, they're proven, and we can explain the outcome. Deep learning, we cannot. But this is very often. So this is very often you need to stand up for this and say, no, we have simpler methods to use this. We don't need the latest and fanciest tech just because we read about it. Of course, it's very important to look into this. But it's not the first thing to look at. And the other thing is also, like senior management maybe say, we have all seen this before. It's just like a hype. And actually, they're right. I did some research. I have MIT Technology Review has all past issues back to the 1895, I guess, online in the archive of the PDF if you're a subscriber. So actually for a talk I never did. I had another project, but I saw while I was looking at the old issues, I saw stuff like this. So in 1998, we have Can Computers Create Literature? Okay. Oh, I just gave a talk last year at PyData Berlin about text literature, like not literature, but producing text with AI. And yeah, that wasn't that successful. What about Beyond Artificial Intelligence in 1 year later? And then in 1987, we see How to Keep Mature Industries Innovative. Oh, this sounds like very much like electrifying automotive nowadays. And also other issues like automation. In 1985, there was also a lot of interest in the industries. There was a lot of automation going on. Also like agile, lean management, Kanban. This goes back to the 80s. This is not invented by computer or like IT and tech. Actually, this comes from production industry. We just think we're like super cool because we know agile and lean. No, it's old concepts. And also like this, I thought that was really funny. And from 1986, after 25 years, artificial intelligence has failed to live up to its promise. Okay. But also since 1988, we know, don't believe the hype. But I think we have to look at the pattern here. Because with AI history is now 70 years. So we have to see there's a constant progress and challenges and things to solve. So we see there's progress here. So it's probably you also see sometimes wave, golden age, dark wave, ups and downs. And maybe deep learning will hit another down soon. We don't know. Maybe not. That's nice. Recently, I saw Kasparov. Kasparov, when I grew up, Kasparov was a rock star. Kasparov was the best chess player in the world. So, and he gave a talk recently in Lausanne, and he was on stage, and he played against the computer. And all these people here who basically built the theoretical groundwork for what we work on computers today said, once a machine can beat a human in chess, they take over, they have won. So, okay, Kasparov, he was the brain's last stand in the 90s. I remember that. We still live. Computers still have taken over the world. I'm not saying, we see also like progress here. So, of course, all the stuff from DeepMind is better than the players here. It's quite interesting. But I think this is the best point he made. Actually, he was citing Pablo Picasso because he said, computers are useless. They only give us answers. And let me also introduce you how we basically address like getting literacy a little bit better in the head of clients and decision makers. So this is now about demos and magic. And one really good approach from Go Data Driven actually is I stumbled across, Vincent. He also just gave a talk earlier today. He's from Amsterdam, and they did a game where basically the data scientists have to play and create value for the company. There's a blog post about it. Just read about it. We did Jupyter Notebooks with the Titanic. Titanic is super boring for everybody who's here in data science, computer science, but think Titanic is still super instructive if you are new in the field or if you're just curious how this works. So I put an executive summary here. Titanic data instructive example. You can learn about how to make predictions, how to make bad predictions. Like, for example, hey, all the women die, all the women survive, all the men die. We already have 80% accuracy. We all know that. If you're not, you know now. And this is very extractive about domain expertise, and it's a really nice example. Everybody understands Titanic. And so it's very nice to also present this in just like 1 hour with not too much code to management people. Or something like this.
Once upon a time, there was a little mermaid named Siren who lived with her stepmother under the sea. She didn't get to go out of the sea like any other.
Okay, this is a synthesized voice. Was trained on Tacotron too. And what's the main takeaway here? It's not about we can do speech synthesis nowadays. No, the main takeaway is I trained it on this MacBook in the eGPU in 9 days of training. It can read English text without cloud service. It's probably not the super production ready, but this is like, come on, this is no budget for some output like this. It's not $1 million budget. My MacBook is maybe less plus the time. And then also you can explain this is scalable, and you have an instant application like reading text. And many people don't know this. They think, oh, it takes all a long time. Yeah, this is what I would skip. This is just like, this is the network. I would explain it to you, but the executive here, the summary here is high quality data plus a cleverly designed neural net produces this outcome at a very reasonable budget. The same or similar, I won't go deep here, is like data signal and predictions. So actually, did you know like style transfers? This is actually just like a prediction of this picture using this style. It's a convolutional network. You can just like, we simplify the data and apply another style. Have to speed up here a bit. So this is like a short video how a network trains, but it's very instructive to see people, oh, okay, this is how the network is learning and how it's flickering. You see, we're just like evening things out. It's people can feel how it works. People don't want to read math or hear too much PowerPoint stuff, and you can explain things take longer. This is just like some examples. Say, hey, all fancy style transfer, all like everything in my slides is style transfer. Fancy, 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 but what I also like to show people, it does not really work all the time. So after it's like, it's just like a picture from the beach, but you always see like this hole here. This is not working well. We can reason about why. So it's a very good explanation. People can see, you just not throw AI at it and it will always work. Because one great thing is we have a lot of open research papers plus the internet plus the news. So there's at least one news about, oh, some researchers somewhere found this. You can do this with AI and will change the world. But the summary here is papers demonstrating impressive findings, but following progress is important, but only 95% of the research actually survives in production. There's some other reasons now. So it's not all you read about will actually work out in the field. And also people should be aware about adversarial attacks, because the network is not just like better, like a perfect machine. Actually not so perfect. This is like a really nice example how some two researchers fooled Yulu here. So because just like of having this picture in front, he's not recognized as a person, where we actually see, we think like object detections and identifying people is basically really solved and scalable, but it's not. It's like, just take this picture and you go look it up in video. So the summary here is neural networks are not perceiving reality as we humans do. Neural networks may be fooled, and they are better and faster at many things, but they are not really good in transferring knowledge as we do. So I think to solve it and how to get it going, I think to sum it up, I think it's important to team up to establish an open, honest, and respectful communication culture. So I think very often I'll tell to clients, come to a Python conference, see the communication culture, the respectful communication culture we have established. Because the Python community, I think one thing that makes us great is you can talk to an astronomer, you can talk to a web developer. We have many different perspectives to look at things. And I very often reach out to astronomers if, for example, we have like really tricky questions. Do you maybe have a solution? Because astronomers deal with big data for a very, very long time. It's not just the internet. It's very open to, and don't expect this to work overnight with one meeting. It's all about trust. It's respect. Very often, I see a physicist or somebody at a client, and I probably know we should improve the coding skills and thing, but take the time and take the space to communicate it. And then, for example, part of my job or our offering is like to enable people. How can we bring ideas to production? How can we experiment? How can we make all this fly? And yeah, if you like the pictures in these slides, because they were all made with style transfer, that's why it's really easy to take all the pop culture pictures, just throw style transfer at it, and it's here. So also we had some happy people here. Our booth is just in the main hall. We have a photo box. You can just like go there and take a picture, send it to yourself, have fun with friends. And yeah, thank you very much.
We do have time for questions. Rachel.
Thanks for your talk. What types of resources or additional learning do you generally suggest to managers that you work with if people want to learn more?
I think it's very important to give them an oversight. This is the technology. This is where we come from. Also, like to give them better definitions. Because, for example, there's big data. What is actually big data? Many people think with 2 gigabytes this is big data. We say no, it's not. But try to not to put it in figures. Just like I'm always trying to establish other pictures. So big data is you basically, if the handling of the data is a problem before, if you can save it on a drive or in your center, it's not a problem. I think it's very good to give them an overview, and always, for example, if we prepare a training for this, we always keep the schedule flexible, because you never know what the real interest is, because we always ask, hey, what are your real problems you want to solve? Where are your pains? How can we help, basically? So, and then usually during the training, the interests move a bit, and then we go a little bit more into the machine learning space, or we address deep learning, or we very often say, okay, we can just solve it with stats, actually. And very often we see, okay, the suggestion is very often, okay, you have to establish a better communication culture. You're facing data silos in your company, and we show how we can solve it with open source. So we always try to push for open source solutions as well, which is in Germany not that simple, because it's still a new thing for many enterprises. That's how we tackle it.
Thank you for the talk. So we experience that often there's a translation problem between data scientists and managers, where data scientists obviously know a lot of the data and techniques, but managers have a difficult time coming up with how data science can help them in their daily work. And then they come up with things like, what is the revenue of this customer in 2 years if Brexit comes, yes or no, right? Ideas that are just not feasible. And so we're thinking about educating them. And we don't have such a good experience with your idea of giving them the Titanic data set, because if you make it easy enough and then they just have a good time and they think, oh, this is cool, but they still don't understand what data science can't do, which I think is often more important. So I would like to have your opinion on educating them more about the concepts and the structure, but don't really do hands-on data science.
No, actually, we don't. It depends. It depends on the team and how we evaluate first who are our peers. Is somebody with programming skills? No programming skills, we do no programming. And I was simplifying with the Titanic sample before. Here the main message was, okay, it's boring to us, but probably not to other people. But of course, and the rest is basically flexible. It depends on the group we work with. So sometimes you just need to explain the Titanic example, and you see, okay, there's other opportunities. But very often we come back, okay, how's your data pipeline? How's your data stored? Is the data even accessible? Which is like, I would say, the majority of the cases. Yeah, we have all these ideas in our head, but we cannot make it happen before we have data pipelines production ready and accessible in the company. But usually we don't try to go too deep into tech and code, because many people are just like afraid of code, because we are used, like, even you can like think about just show a JSON file, which is like super simple data structure. Just show it to your parents and they will say, well, what is this? This is just like gibberish. This is just like random characters on an empty page. We very often forget, because we scan these patterns, JSON code, and it says something to us. And even very good code is like just gibberish if you're not used to it.
We have time for one last question.
Hi, thanks for the talk. It's great. I recognize a lot of the things you mentioned. I wonder, do you have any experience with, like, so we are in data science, so what we can do is for those businesses make predictions and all that kind of things. I always have a very hard time explaining that many of the things we find are not causal relationships. However, as a follow-up, they do want to take action using the models.
Okay.
But how, and they always hope to see like, okay, if we can like tweak this button, then this will happen. But often the data does not allow you to make these kind of conclusions. So you have any experience with that? And how do you
actually, we try to, I mean, it's always like, how can we say it? It's like a balance, because very often we are faced with clients as well. They have big expectations. Of course, as it does, if they hire us to help them build the models and get work, of course we want to deliver, but sometimes there's nothing to deliver. It's just like not enough. The data quality is not good enough. It's not, we cannot really say, and we are just honest. And I think another example can be, so many people want to use the latest tech. So, for example, we need a Kubernetes cluster. Then, we just like prototyping. Where's the Kubernetes cluster for? If we go to production and if there's many machines, we probably will use it. And sometimes it's not easy, even for me as a senior person, to stand up, because of course you want to also win the client, you want to work with the people, and you want the business. But on the other hand, we'd rather say, okay, no, we say this is how we do it. This is our perspective. You don't need this. We can smart smaller. We are your advisors, and very often, honesty is trust building, and then you can have the follow up business as well. And if for us, that's basically in how we see also our businesses. I mean, if the client just wants to have the hype and have some results to present something, we say it's not a good fit for us. It doesn't. Then we'd rather not work with the clients, because we want to. Our mission is to enable them. That's how we see it. And then you sometimes have to say no, also, even if it's hard.
Thank you, Alexander.
Thank you very much.